In this video, we're going to do 13.01 letter-count. I have the file downloaded and opened up in Racket. So let's just find the problem statement, right? So problem A, notice that the data design steps are done above. All right, so here's a little done. Let's just review that. We have list of string is one of either empty or cons string list of strings. So it's a self-reference. Here's the interpretation, a list of strings. They didn't give us the data examples. It's fine. We're going to do them along with the function. And here's the template. All right. Design the function letter-count, which consumes a list of strings and produces the total letter count. For example, letter-count of cons moo on cons wolf empty produces 7, because there's 7 letters in total, right? 1, 2, 3, 4, 5, 6, 7. All right. Finish the uncompleted function design steps 1 through 5 above. All right, 1 through 5. All right, so pause the video and try to do this on your own. Go with spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it. So now let's go over it together. So first comes the signature. So letter-count consumes a list of string and produces a number. So the purpose is that produces the total letter count of all the strings in the given list. Next, stub this out. So define letter-count consumes a string lst. That's what I named the template variable here. So I'm just mirroring that. All right. You can choose whatever name you want. Just be consistent. All right. Produces a number, and I choose 0 as its dummy value to run against some tests here. Letter-count. All right, so what's the letter count of an empty list? Well, 0 sounds like a good default. What about the letter count of this example that they just gave us, right? Like so. Going to copy that in. So they said that this was 7 letters in total. And let's do one more. That's just one long, right? Check, expect a one long list. So cons, ice cream. All right, that is 1, 2, 3, 4, 5, 6, 7, 8. 8 letters in total. All right, so let's just run our stub against the examples here. Looks like we got an error. Cons expect 2 arguments, but only found 1. So, oh, I forgot the empty here. Whoopsie daisy. Now the stub should run fine against the test. We should just get mismatches, and we are good to go. All right, gonna come out the stub. Next is the template stub. So let's just grab the starter code here. Paste it down and rename letter count like so. All right, so now really pause the video and try to work through the solution for letter count on your own. We'll go over spoilers in 3, 2, and 1. All right, so hopefully this should be all the mental scaffolding needed to complete letter count. So let's just go over it together. So letter count in the empty list case, right, the base case should produce 0. Let's try that, right? All right, now for the harder part, right? So what do we need to do with this first? These are strings, right? So this is a string, but we need to turn this string into a number. So let's look at things that consume strings in documentation, right? So we have, let's see, symbols, booleans, lists, strings. Here we go. In this case, I know that we're going to need string dash length, right? Which consumes the string and spits out the letter count. All right, so we're just going to wrap this around a string dash length. All right, so we're almost there, right? We've got the length of these strings, so this is 3. And then in this case, when it hits the recursive call, this one's going to be 4. So the combinator is adding these two together with plus, right? Because this is a number, and this will resolve to a number. Speaking of this case, right, we have to rename the recursion here, right? So we want to add the string length of the first of the string to letter count, which we will assume will follow the purpose statement here, right? All right. And it works, and we are good. All right. So now let's quickly go over how it works at a mechanical level. Again, don't be too concerned with it. Just trust that the recursion works. But nonetheless, it's an itch that it's really hard to really not want to scratch, right? So what I'm going to do is I'm going to come out the first 2 tests and focus on stepping through the most complicated test here, which has 2 letters, right? 2 characters, 2 words, moo and wolf. All right, so let's just step through this. So empty resolves to that. All right. So we're going to do the letter count of this. We're going to call letter count with cons, moo, and wolf. And it's going to expand to this whole cond here. All right. So is this empty? No, it's not empty. All right. So I'm going to put this in table format here. So like so. All right. So it's false. Means that we're going to take the else case. So like so. And we're going to do the first of cons, moo, wolf, which is just moo. And then we're going to take the string length of that, which is just 3. And we're going to add that to taking the rest of moo and wolf, which is just wolf. And we're going to take the letter count of wolf. All right. And we're going to take the letter count of wolf. We're going to do a recursive call with the list getting smaller, containing only wolf and then empty. All right. So is this an empty list? No, there's wolf inside here. All right. There's a string wolf. False. So we hit the else branch. And then now we're at the first of this list, right? So first of cons wolf is just wolf. All right. String length of wolf is 4. There are 4 letters in the string wolf. And rest of cons wolf empty, right? So the rest of this is just going to be the empty list now. And we're going to call letter count on the empty list, all right? Which expands to this cond. And this empty list, is this empty list empty? Yeah, it is empty. So we're going to hit the base case of 0 here, like so. So it's going to produce 0. And now we have all the terms in the addition expressions now, right? All the string length in addition form. So 4 plus 0, so that's 4 plus the base case, which is 4. And then 4 plus 3 is 7. 7 plus 7 is 7, and that is the check, expect, pass, test, passing. All right, so let me just quickly put this in table format. So we know that the first iteration was false. The first of the list is moo. So I'm going to copy it over here, like so. String length of first of list, the list. So this is the first list, it's moo. We take the string length of it, it's going to be 3. And the rest of the list is just going to be this part, right? So like so. Delete that extra parentheses. Second iteration of the call, right? We're doing a recursive call. It's going to be this. This is not an empty list, right? There's wolf in here. The first of this list is wolf, so I'm going to copy that, like so. How long is the first string length of first of LST? This is first of LST in this column. So wolf is 4 characters long. And what is the rest of the list? Well, this is the current state of the list. It's this empty list here, like so. Now we're at the second step of the recursive call. Empty list, is this empty? Yes, it is. Right, so now we hit the base case, hit base case. All right, this would be an error if we do a first list, but since we hit the base case, the value is 0, so base case 0. All right, and likely if we call rest on an empty list, it's going to be an error, so I'm just going to write that there. And of course, we do 0 plus 4 plus 3 in the format you saw earlier to get the number 7. And you can check these for check, expect, letter count of cons, ice cream, empty, and you should see 8. All right, and just to verify that this works for a long 3-length string, why not? Let's just write this in. Let's write another one, cons, meow. All right, so meow is 1, 2, 3, 4. 1, 2, 3, 4. All right, what's 7 plus 4? 7, 8, 9, 10, 11. So it should equal 11. So this test should pass. So we should see 4 tests passing if I comment out the tests I commented out for the empty case. So we get 4 tests passing now. All right. Anyways, hand in your assignment to the grader over here. It's called 13.01. 13.01 letter count, and make sure it passes the grader test that I wrote. All right. And that is about it for this one, and I will catch you in the next one.